Welcome to another Q&A. This Q&A is actually one that comes up quite often when people have got reverse osmosis systems, whether it be an IPC Eagle, a Zero, a Blue Dragon, or a Flow Red, and it doesn't really happen very often with Flow Red Plus. And it's how do I get a radial brush to work with my reverse osmosis system? Right, so it's quite a complex answer, but it's simple. I'll try and make it simple. So the first thing is to understand that what we're looking for is 1/2 gallon per minute from the radial brush at the end of your hose and your tube, and with gravity and the effect of gravity and everything like that, pardon me. So you need to reverse engineer from there. You start at the brush and say, I need 1/2 gallon per minute. What water flow rate have I got at the tap? That's almost always greater than 1/2 gallon per minute, right? That would be really rare that you can't get a high flow rate from a tap, but it does happen from time to time, and that creates another problem, right? Then the next thing in the system, you've got a sediment filter, and if it gets clogged, it's going to slow down your flow rate, so you want to make sure you've always changed your sediment filter. The carbon filter shouldn't take very much water pressure out. And then we've got reverse osmosis, either a 40-40, which is a 4 inches wide, 40-inch tall reverse osmosis membrane, or 2 times 40-21, which are 4 inches wide and 21 inches tall. So they basically, 2 40-21s will produce pretty much the same performance as a membrane of the same model, which is a 40-40. So then we start talking about the model of the membrane. Now, if you go back, when we designed the Zero Pure system, which was called Wash It Pro, then if you go back to those days, we were using Axion ULP membranes, and we were putting water out through 2 or 4 pencil jets. Like, we were the first people, I think, to bring out 4 pencil jets on a brush with a Beta brush pack. And from there, we went to Constructor Brush, and other guys have got their rinse bars, which are pretty similar in flow rate to the Constructor Brush. And then we went to Radial, where we went to the higher flow rate for a faster rinse and a more effective rinse into the corners and down the outside edges with spider webs and spider nests and stuff like that. You need a lot more water to get those to clear off the glass really quickly. So it's the model of the membrane which is going to determine the performance of the reverse osmosis system, right? So all RO membranes are not the same. Most of them are tested at 150 psi, so they're not really, they're called ultra low pressure. It would be the normal one that you'd find in a window cleaning system, but they're not thinking about 1/2 gallon per minute, these other systems, because most of these other guys are selling either pencil jet brushes or fan jets, which are similar to pencil jets. They just put a slit in the jet so that it fans, but it's the same flow rate, or the same orifice, size of the orifice is probably more accurate. Or they've got a very low flow rate jet stream, squirting straight jets out of the brush like we had with Constructor Brush, right? And so the mix and match is a challenge. And then when we talk about flow and flow red, maybe flow red came out even before radial brush, or before radial brush was perfected, to all of the radial brushes from the big range, not the light and the ultralight, are all, standardized to 1/2 gallon per minute, 2 liters per minute flow rates. So sometimes there's nothing you can do about the membrane. That's probably my point. If you have a flow or a flow red, maybe you can update to the latest membranes we've got, because they are even a higher performance or a less resistance for lower pressures, right? That's what we've always focused on, is finding the membrane material that will deliver more flow rate with less pressure. So you may change the membrane, and sometimes I have phone calls with guys that have just gone off and bought a membrane, and then it's not working, and it's not working as well as the one they got with the system, or it's not working as well as what they want, and they didn't understand that there are different membranes with different characteristics, because reverse osmosis is a $1 billion industry, probably, something like that. It's a massive industry. So there are lots and lots of different membranes for different functions and different purposes. So there's an issue with whatever reverse osmosis membrane you've got and what its performance is. Now, doesn't matter which membrane you've got, if you create enough pressure before the membrane will deliver more water. There's no doubt about that. So step one is you add a pump as a booster pump to increase the pressure or the PSI in front of the membrane. And that will increase the flow rate through the membrane. And the higher the pressure, the higher the flow rate, right? It's quite linear in that sense. So you can use a booster pump. Now you look at some of the booster pumps that are available on the market. There's an RHG booster pump. It's a magnificent solution. It's a marathon motor with a fluid tech rotary vane pump. It's perfect. You know, it's the ideal system, but you might need it because it can create more pressure, right? Than for example, what we might say is a Wayne PC4 pump that you can buy at Ace Hardware, Home Depot, Northern Tools in America, or you could find it maybe in Bunnings or Mitre 10 in Australia, kind of thing. So we suggest the Wayne PC4 or the Liberty 331, which is like a $250 pump, maybe $300, depending on inflation right now. And the difference between the Wayne PC4 and the Liberty 331 is the Wayne PC4's got a cast iron housing. So you've got to flush it before you connect it to your pure water system, otherwise your sediment filter will fill up with the rust. And the Liberty 331 has an aluminum housing, which means it doesn't oxidize when it's not being used, so you can just connect it normally. So we normally gear people towards Liberty 331. And so that if you boost the pressure before the membrane, you're going to get a higher flow rate. However, first you must understand how a membrane works. A membrane doesn't work just because it has pressure before it. It actually works on the pressure differential across it, right? So if you have a lot of pressure before, but you have a lot of resistance afterwards, then the pressure differential across the membrane is reduced, and then your flow rate will get reduced. So you have to balance, you know, again, we're looking at half gallon a minute, 2 liters a minute at the brush. The hose and the tube that you choose, if you're using a 8mm 5/16 OD outer diameter tube, then that's going to have massive resistance. It's going to reduce the flow rate, right? And the pressure behind it will build up. When that pressure builds up, where's it building up to? It's building up to the RO. So it's creating a back pressure is the best way to look at it. It's a back pressure against one side of the RO, and you've just increased the pressure against this side. But the difference in here is what's actually going to give you some performance. So then we would recommend that you go to a 3/8 inch OD tube, which we call high flow in our range. So high flow tube, and no more than 150 feet, but the longer it is, the resistance is cumulative. So the longer you make the tube, the more the resistance, the greater the back pressure, the less the pressure differential across the membrane, and the lower the performance of the system. So firstly, you're going to increase the internal diameter of the tube, even though we talk in outer diameters, but it's actually the internal diameter is what's determining the water that can actually go through it with less resistance. And then, so if you have a problem with that, then you might think, okay, the best way to get the maximum performance out of whatever RO you have, rather than buying a new one, is to separate your back pressure, the resistance and the effective gravity, and from the length of tube and the gravity to get to the glass, you could separate that from the inward pressure that's coming in from your pump or your water supply. And you'd do that by getting a buffer tank. Could be 25 gallons, 100 liters, and you could get that from tractorsupply.com, TTI in the States, or you can get it from sylvan.com.au in Australia. And then that little buffer tank, often they come with little delivery pumps, little 12-volt pumps on them. And the ones that we've always sort of pursued are ATV, we would call them quad bikes, so all-terrain vehicle, the four-wheelers, like that, the chemical spray units that they put on the back of those. So you can get, those or bigger, but basically that's the logic where you say, okay, now under difficult conditions or poor performance conditions, I will deliver the water from the reverse osmosis membranes into a tank. So now your back pressure is now zero, right? So now whatever pressure you've created with your town supply water and your booster pump, whatever pressure you've created, now you have the maximum pressure differential across the membrane. So that will give you the maximum performance of the RO under whatever conditions you're dealing with. And then the delivery pump is now focused on pushing the water through the hose, through the tube, up the pole against gravity and delivering your ½ gallon a minute. So you can isolate, that issue rather than having to go to bigger and bigger pumps. But the other way is to go to the Marathon Fluid Tech rotary vane kit, which RHG sells, right? So those are your options basically. Increase the pressure massively against the membrane and then deal with the back pressure because you've got massive pressure, or separate them, put the buffer tank in and have a 12-volt delivery pump dealing with the resistance and the head of gravity. And then there's one other thing that this question comes up always at this time of year. And the reason is that the performance of all reverse osmosis membranes is very much affected by the temperature of the water. So as the water gets colder, it becomes less viscous, more thick, if you can imagine that. And because we're trying to push water molecules through tiny little holes where only water molecules get through, and molecules that have got a carbon, they have carbon, but carbon, calcium, nitrates, sulfides, magnesiums and all that, those little molecules don't get through. That's basically what's happening in an RO. Then because the water is more dense, then the performance of the reverse osmosis membrane drops. And it's all RO membranes because of the nature of what reverse osmosis means. And so at this time of year, especially, it doesn't matter, it doesn't happen to the guys in Florida and California and Texas so much, but unless they have a really cold snap and then they'll notice it. But the guys up in Canada, north of America, Michigan and places like that, New York, right? They really notice it. And if they've just bought a system or they just bought their RO system last year and they go into fall and the ground temperature's good, then the system was performing well, and then they come out of out of winter and they're in spring, the ambient temperature, the air temperature is fine and it feels like it's warm, but actually the ground hasn't thawed out yet. So the water that you're dealing with is coming through the ground is cold, and so therefore the temperature of the water is cold, therefore the performance of your reverse osmosis membrane will be less. How much less? Well, at 77 degrees Fahrenheit or 25 degrees Celsius, the RO membrane performance is double what it would be if the water temperature is 39 degrees Fahrenheit, 4 degrees Celsius. Right, that's the bottom of the graph, right, is that temperature there. So, and it's quite linear between 39 degrees and 77, or between 4 degrees and 25, depending on where you are in the world, what you use. It's quite linear, right? So as that temperature goes up and the water temperature goes up, then your performance of your reverse osmosis membrane goes up. So at this time of year, guys may need to use a booster pump, not because their fluid dynamic system is wrong, but because their reverse osmosis membrane is, significantly affected by water temperature. So that is the answer to the question. It's not about the brush, right? ½ gallon a minute is not a high flow rate. It's just, you determine my outcome is ½ gallon a minute, and then you work your way backwards to your water supply, and then you modify and adjust that. So when you hear us talk about FlowRed Plus as a pure water system, the plus was plus 1 litre a minute, or it was a little bit over 1 litre a minute that we were able to create by changing the internal design of and the membranes from FlowRed to FlowRed Plus, which is about 1/4 gallon a minute. And we had to do that because we wanted FlowRed Plus to support radial, and we want radial to have ½ gallon a minute. For the other guys who haven't got a radial brush yet and don't want to, are not ready to, don't believe in, don't understand, or are determined to stay with lower flow rates, then we have We have a low flow rate range of brushes, which is called Radial Light and Radial Ultralight, and you can buy those either as high flow or as low flow, which is about 1/4 to 1/3 of a flow rate different, lower, that you can operate those brushes. And you can also buy them with interchangeables, so you can actually buy both sets of jets so that you can change it later on in the season or something like that. Like, it's really aimed at the European UK market where they carry their own water and they're scared to get a high flow rate brush. You don't know you can clean faster until you clean faster, so when you're buying it, you don't believe that you can clean faster, so you buy a lower flow rate because you're still running the paradigm of where you came from with whatever you've been doing. So they look at it, the flow rate is, 1/2 gallon per minute. I will go through that water too quickly because they think they'll take the same amount of time. Once they get radial and the radial technique, they realize they can clean 2, 3, 4 times faster, so they use less water with a higher flow rate than they would if they had a low flow rate. So that's why we make it available for everybody to be able to make that decision and experience the efficiency of a radial brush directly. All right, I think I've said everything that needs to be said on this topic. So that is it. If you like this, do go to youtube.com/future of cleaning and look up the Reach It workshop, subscribe, press the notifications, click all, and then you'll see me put out these close to one a day is what we try and do. If we've got the time to do it, then we try and put out one a day, and the questions are based on questions that we get asked from customers from time to time. So this question was fresh today. Okay, see you in the next one.